This is a quick overview of the Gerber pick-and-place visualization tool I put together. This project's available in GitHub from the link in the description. Purpose for this tool is to streamline the process of manually placing surface mount components when you're assembling a printed circuit board. What the tool does is take care of the tedious cross-referencing of components on the board against the bill of materials and makes it easy for you to find where each part belongs. Here we get the tool up and running, and for starters you can see that there's a relatively realistic graphical rendering of the top surface of the board. In the right-hand column, there's a list of parts from the bill of materials. Key thing to note here is that this list has been filtered down from the full bill of materials to show only parts that are surface mounted and only parts which belong on the currently visible side of the board. You can flip to the other side of the board and you'll notice the parts list updates accordingly to show the parts that belong on this side. You can click on any of the parts in the list and the locations of those parts on the board will be highlighted. This saves you the trouble of having to search for the right reference designator on the silkscreen to figure out where the part belongs, and it's especially useful in cases where the silkscreen is not enough. Either you don't have a silkscreen or your silkscreen is illegible, poor quality, not on both sides of the board, etc. Or in cases like this where there's a lot of very small components packed together and there wasn't room to put silkscreen items for all of them. By default, the items in the parts list are grouped. So if you click on one, you highlight all instances of that unique part number. You can also drill down if you want to highlight them one by one. Now let's walk through the process of actually using the tool. For starters, you got to get it installed. There are instructions on the GitHub project in the wiki on how to do the installation. There are a fair number of steps because there are a number of compatibility issues with various packages that are required to run this tool, but all the instructions there should get you through it. This tool operates on CAM output files from the Eagle CAD software, which was recently acquired by Autodesk and has now been incorporated into Fusion 360, so that's how I'll be showing it to you today. The files you're going to export here are similar or identical to what you'd send off to a board house to have the board fabbed. Here I've got my board design open in Fusion. Let's just go to Manufacturing, CAM Processor. And instead of the default CAM processor, you just need to use the one that I supplied with the project. See, it's there. Process job. Pick where you want to save the files. And that's done. Let's take a quick look at what files are actually generated by that. So if you go to that target directory, see there's this CAM outputs folder. In there are your set of Gerber files. Gerber files define all the layers that make up that board: copper, silkscreen, solder mask, outlines, etc. Drill files defines where the holes are drilled. The assembly folder contains the bill of materials and pick and place files for the front and back sides of the board, which defines the location of each one of those components. Done there, so I'll launch the tool. File, process Gerbers. You need to point it to the location where your output files are. The tool will tell you that it's processing the files. It takes some time because it has to render the Gerber files to create the board images. The images are fairly high resolution, so it takes some time depending on the size of your board and how powerful your computer is. Give it a few minutes. And the rendering is complete, so we're ready to go. Pop back over to the CAM outputs folder for a second. See, there's a few new files here that were generated by the rendering process. There are the rendered images at the top and bottom of the board, and an INI file that contains some other information about the board that the tool needs. When you open up a board that already has these render files present, it does not need to go through that rendering process over again, so it'll load almost immediately. The tool does check the timestamps on the Gerber files, so that if the board has been updated since the last time the rendering was done, it will trigger a re-render. So that's about it for getting started. I will be posting a follow-on video to explain some other features that are tailored for some more specific use cases. Keep an eye on the GitHub project for any fixes and improvements going forward. I welcome any feedback, bug reports, feature requests, etc. And thanks for watching.